Hello, good morning, good afternoon, or good evening, wherever you are in the world. Welcome to this new Hdpa World webinar. My name is Jean-Luc Clemens. I'm the director of the telecom activities at Hdpa World, and it's a pleasure for me to welcome you to this new session. As some of you have maybe joined us a couple of months ago, we have launched a series of webinars that are focusing on fiber technologies and new fiber technologies especially. During our last webinar, we have talked about ODN and the development of ODN. Today, we will focus on the new development of GPON technologies. I will be joined today by a series of distinguished speakers who have agreed to join us today and to share their experience with us. Today, we basically will have with us, together with my colleague Roland Montagne, who is our FTTX expert. I will be joined by Mr. Chang Jeji from China Telecom, who's a broadband research expert at China Telecom. I will be joined by Mr. Burak Dogan, who's an access transport network technology manager at Turkcell. We will have also participation of Mr. Li Junwei, who's a senior researcher at China Mobile. We will also have a presentation by Mr. Robin Kung, who's a technical expert at Sumitomo Asia. And finally, we will have a presentation done by Mr. Jacob Machen, who's a product definition specialist at Semtech. Just to give you some context and why we have decided to address this topic today, clearly we can see that the gigabit society is a key pillar for the digital transformation of our society. Just taking the example of the European Union, the targets that have been set by the European Union are extremely aggressive. All main schools, hospitals, public services should have gigabit connectivity by 2025. All European households should have at least 100 megabit per second by 2025. And all urban areas and major roads should be covered by 5G before that date. As I guess all of you have seen, the EU Commission has published a toolbox recently which aim at sharing best practices in order to reduce the cost of the rollout of the high-speed networks and the 5G rollout. The EU is only an example here. I'm sure you all have seen the declaration made by President Biden in the United States and the role that digital infrastructure will play in the package that have recently announced. All those public support coupled with the private support will lead the gigabit infrastructure to accelerate in the coming years. According to EDAT forecast, we will reach 2 billion 5G connection by 2026, and we will be very close to 1 billion FTTH connection by 2024 worldwide. So what we have seen in the last years in terms of gigabit infrastructure growth will continue. The direct consequences of this infrastructure deployment is the need for increased bandwidth. The bandwidth requirement that we have seen over the last 4 years that has seen the worldwide IP data traffic doubling between 2018 and 2021 will keep increasing at the same speed between today and 2025. That means that this increased IP data traffic will require new technologies, especially on the GPON side, in order to meet those requirements. Hence, the decision that EDAT has taken to work especially on that topic and to offer you today this webinar with the various speakers. So basically, what are the challenges ahead? I mean, we know that GPON and 10G-PON is currently under development. We know that the time frame between two technology is about 5 to 7 years. That means that given the increased IP traffic that we will see in the coming years, GPON technology needs to keep developing, keep increasing. And there is a debate in our industry. We know that the follow-up path for 10G PON is shared. There are many debates at the IEEE, at the ITU. We know that there are standards around 25G PON, around 50G PON, and those standards are currently being developed. So the idea here will be, by taking the feedback from the various operators and the technological experts that have agreed to join us today, will be to learn more about the upgrade between GPON and 10G PON. We will also make a specific focus on the 50G PON technology. What can we expect from this specific technology, and basically what we can expect out of it. We will also make this session a little bit interactive. So I will propose to all of you to basically join me in answering this little live poll. Here we are basically asking you if you have started already to deploy it in 10G PON. Let's take maybe 40 seconds if you accept to share with us your experience. Have you started to deploy 10G PON? Can you just click yes or no? And basically, we will have some kind of live return that will feed the debate with our speakers. So I'm leaving you here a couple of seconds to fill the poll. We are about 200 people live now on this webinar. So I guess we should have some kind of nice answers. I hope you had the time to provide your direct feedback. And now let's see what the results are. I mean, obviously, there is a massive answer to say that 10G PON has already been started to be deployed. Thank you very much. That's a very interesting figures. I was actually not expecting such a strong yes, actually. Maybe a second question before moving to the first speakers of today. How much do you know about 50G PON? Is it something very clear to you? Do you know little, or is it something totally out of the box? So once again, let's take a couple of seconds for you to think about it, and maybe to get back to us with an answer. Once again, we take this as a live poll, which will represent the position of the 200 people that are currently connected. I hope that you will have had the time to make this quick answer. Now, maybe let's look at the result. Okay, so basically it definitely says that there is some knowledge about 50G PON in the community. However, we see that there is still a strong amount of people who basically say that the 50G PON technology is not now, which is a good thing, because clearly this webinar has also as a target to discuss this specific technology. So thank you very much to all of you for participating to this mini poll. If we try to move forward, I would basically leave the floor to our first participant, Mr. Chang Deiqi from China Telecom. First operators who will share with us its feedback will present us the progress and the prospect for the 50G PON seen from China Telecom perspective. So, Mr. Chang, the floor is yours.
Okay, thank you, Gerard. So, hello everyone. Good morning, good afternoon, good evening. I'm Dezhi Zhang, coming from the China Telecom Research Institute, and I'm very happy to have this opportunity to share with you on our understanding of the 50 gig PON, especially of 50 gig TDM PON technologies. And everyone, knows that the broadband access network are currently deploying very rapidly in China. So the driving force is diverse, I believe. So the first of all, there is a consensus in the industry that the broadband access network is a very important information infrastructure that supports the digital transformation and the development of various of the industries. So that is a common sense. And for the home and residential users, I believe that the killer application is still high definition video. So the 4K is currently the mainstream application, and industry is very mature, and the content is increasing rapidly. And the development of the 8K industry is taking off, actually. So it might be the future, the mainstream services. And further, and the broadband access network as a comprehensive service access platform carries a variety of the services and applications, such as government and enterprise applications, industrial power applications, smart cities, and so on. So in general, so these applications and the services also drive the continuous development of the broadband access network technology, and also the deployment of the operating network. So that is the drivers. We will have very strong drivers for that. If you're looking back to the technologies, you will see that for the deployment of the optical access network in China Telecom, actually we have both EPON and GPON deployed. If we, in current stage, for the gigabit to the home, the 10 gig PON technology is needed to improve the total bandwidth capabilities of the optical access system. And of course, if combined with Wi-Fi 6 and FTTR, the new technologies, then we can provide a better user experience. But still, the 10 gig PON is still very important technologies to enable the 100 meg to the home. If you look at the PON technologies, the 10 gig PON technologies, the 10 gig EPON and XGS PON technologies are corresponding 10 gig PON technologies for the EPON and GPON respectively. So at present, large-scale deployment is already, in progress. We all know that the standard has been finalized more than 10 years. And we have, for the key components, including the chipset, optical chipset, optical devices, so electrical chipset, and also the system equipment, they are also very mature. They are mature enough, I believe. So that is why, 10 gig PON have already been, massively deployed in the network. And besides, a purpose for the PON, for the ecosystem, this is also another very important aspect that can be enabled by the standards, including including the standards like the OMCI, extended OAM, such kind of, the management channels standards, which we have more and more, the vendors, more and more partners join in this, cycle. But anyway, so the gigabit users, if you look at the current numbers, so this is a number for the February this year. So gigabit users continue to grow, and by February this year, so more than 8 million home users have access rate of the 1 gig or more in China. So that's very rapidly. But if we look at that for the large-scale deployment of 10 gig PON, as we have discussed, we need to ensure that they have sustainable evolution capabilities. This is very important for our network. So we definitely don't want to have one technologies which don't have the future, right? So, but what is the future? So, given the technical analysis and also the standardization development, we believe that the 50 gig TDM PON is the future in our network. So there are some aspects from the operator point of view. The first is that we think that it can be used as a unified next generation evolution technologies for different 10 gig PON technologies, because that's we can avoid the complexity brought by the deployment of different PON technologies, as we have mentioned, the EPON and GPON. So in the future, in the 50 gig era, we have only one generation, that is the 50 gig TDM PON. This is very important for us. The second one, the 50 gig TDM PON can support coexistence with the 10 gig PON, either 10 gig EPON or the XGS PON. So that means that we can support the two-generation coexistence between 10 gig PON and 50 gig PON. And for sure, based on that, we can provide the smooth upgrade of the users, and then also protect his current network investment, including the system equipment and also the ODN infrastructure. So that is another very important for our operators. At the same time, the increasement of the system capacity to more than 5 times, and also have very strong. So this is a very strong market foresight. So you know that this can support a very long period of the new business support capabilities. So you know, as we have discussed, that 4K is currently mainstream services in our network. So when the 50 gig PON to be deployed in the future, we believe that 8K and maybe 8K VR, these may be the mainstream services running in our network. So at that time, the bandwidth requirement would be much more than what we have now. So if we look at what is the progress of the standardization, currently ITOT is currently developing technical standards, and the requirement standards have been released in the 2019, so 2 years ago. So standards such as the PMD and the TC and the coexistence devices are under continuous development, and we expected those the first version of these standard series to be consented and to be agreed in this year. So hopefully the PMTC could be the earlier, and the PMD, we also hope that the PMD can be finalized. The first version of the PMD can be finalized in this year. So that is standardization. So actually there is no mysterious for the for the 50 gig TDM part. Actually, it is very simple if you look at the system architecture and the capabilities. So the downstream is still the TDM, and upstream is still the TDMA. So actually, this is a similar architecture with the 10 gig PON. If you look at the XGS PON or the 10 gig EPON. And for the line rate combinations, that originally from the beginning, we have 3 combinations. So it was 4 line bit combination rates. So we have the symmetric 50 gig downstream and upstream. We have the downstream 50 gig and upstream the 25 gig. And we also have the downstream 50 gig downstream and the 12.5 and 10 in upstream. But in this year, earlier this year, so operators, vendors, and other partners in the question 2 group in ITOT study group 15, we found that actually the optics and system complexity for the upstream 12.5 and the 10 gig, they are similar. And for the optics, they can even use the same optics. So the people think that to avoid the market split, people the group agreed to remove the 10 gig option and to just let the 12.5 gig upstream, this line rate option to be remain. So finally, we will have 3 line rate combinations in the standard. So for the others, if you're working in the PON area, you should be very familiar with this technical features, just like the 20 kilometers, 2-stage splitters, and 1/64 split ratios. They are very typical deployment scenarios in most of the operators' network, I believe. And another point very important is that it supports the large-scale deployment of the ODN infrastructure. And this can greatly save the operators' investment on the ODN. The last point, and also very important point, is that there is new design for the 50 gig TDM PON, 50 gig PON, the common TC layer design. So this is compatible with all types of the current HSP systems defined in the ITOT 50 gig PON standard series. So this is very important because when for the industry investment, a lot of them will be invested in the chipset design and manufacture. So if you have the common TC layer, then people are wondering that maybe in the future we can have the common TC layer chipset to be adaptive to all the future PON systems. So this is a good thing, I think. From the operator's point of view, we think that there is a very important thing is the migration. Currently, as we have introduced in the previous slide, that's 2-generation coexistence. So from the transition point of view, we think that the 10 gig PON and 50 gig TDM PON coexistence with via the wavelength dividing multiplexing method is very important because based on this way, the full system capacity of the 2-generation PONs can be guaranteed. The first and second, for the user experience, we can just easily upgrade one user's access capabilities just replacing the box, replacing the own box at home. So just on demand. So this is very convenient. From the network construction point of view, we think that the NPM mode scheme is the preferred method. So we have the two methods defined in the standard. One is the external box, and the second one is NPM mode. But from the operator point of view, from telecom point of view, we think that the NPM mode has many advantages because it can save the room costs, something like that. And the second one, also we have some technical requirement for this NPM mode. So we have defined the 29 and 32 OPL classes, which can support the legacy 10 gig PON ODNs, including the class B+, C+, and PR30. So this is also very important to guarantee the migration and coexistence. We do acknowledge that there are also some technical challenges for the 50 gig PON. The first one is that the power budget. So this is very important things. Currently, the line rate has been increased to the 5 times. And this will lead to the challenging receiver sensitivities. Dispersion penalties is further increased, we think. So technical innovation is needed here. We need to detect breakthroughs for the technologies to realize the higher optical classes, including the 29 dB and 32 dB. This is definitely required. And for the dispersion compensations, the system, when the line rate is 50 gig, the system dispersion, the tolerance is much smaller, giving the theory. So in the standard development, we select the O-band to reduce the dispersion of the fiber transmission. And second, in the 50 gig PON, the Dsp technology can help here to mitigate the dispersion impact. So, in the 10 gig PON, we don't need the Dsp. But in the 50 gig PON, Dsp might be needed, we see. And the last one, we think for the commercialized, for the system equipment, the packaging and the power consumption control, this is also a very important point to need the technical innovation here, because the NRZ modulation with the high baud rate will lead to very high requirement for the packaging of the optical devices. And second one is that we do have the large transmit power to achieve the high optical classes. Then the very large transmit power and with a high line rate, which will lead to we will need very strong cooling technologies. So this is also very challenge to realize to make the system equipment. I would like to report some of the latest test progress to all of you. The high-speed 50 gig PON prototype schemes was successfully verified in the current network ODN simulation environment, and also service transmission rate in the downstream of about 40 gig bps is achieved. And on the similar environment, the OE registration was completed online, and the normal operation under one of the typical ODN environment of the 1:32 ratio and 10 kilometers optical fiber distance. So that is a good result, I believe, and which can encourage our industry. So finally, we are very happy to cooperate with academia and industry partners to promote the technology innovation and applications deployment of the 50 gig PON. So that's all. Thank you very much.
Very much, Mr. Chang. That was a very interesting presentation. Just for the audience, you may see in a box around somewhere around my head, there is a box for Q&A where you can post questions. We will have a Q&A session at the end of the presentation, so feel free to feed your questions so that we can answer it at the end of this seminar. Moving forward, I would like now to welcome our next speaker, Mr. Burak Dogan from Turkcell. who is an access transport network technology manager. Turkcell is today one of the FTTH leader in Turkey, and Mr. Dogan will here present us how Turkcell is moving ahead with FTTH and how this translates in terms of demand for a next GPON technology and 50 GPON more in details. So, Mr. Dogan, the floor is yours.
Hello, everyone. This is Burak from Turkcell. I'm Access Transport Network Manager. So in this webinar, I intend to talk about the progress of FTTH deployment and the demand of the 50 GPON in Turkcell group companies. So to understand the importance of FTTH and the next generation PON in Turkcell, we need to know what is Turkcell is. We can answer this question with Turkcell is a digital operator. But what does it mean, you may ask? Turkcell is not only a mobile carrier or internet service provider. Turkcell also creates a digital services to enhance customer experience with the solid network infrastructure. In the last investment relations report, we can clearly see that this diversified business model working like a charm for Turkcell. Strong revenue growth in digital services and digital service standalone with 26% and 62% in fintech business. In addition to that, we are getting more and more subscribers with increasing IRPU. When we focus on the FBB business in Turkcell, Turkcell has 3.8 million home passes and increasing aggressively each year. With the COVID-19 pandemic, FBB services became critical asset for homes. Because of the lockdowns, nowadays our homes also our offices and class for our children. As an operator point of view, we can clearly see increasing demand for HSS services, more than ever actually. And we can see Turkcell fiber and IPTV subscriber trends as a result of this. Turkcell managed to cover this increasing demand with solid FTTH network, which we can deliver up to 10 Gbps on demand for our residential customers, thanks to XGS-PON technology. We also really focus on the customer experience at home. So we announced Wi-Fi 6 as the first operator in Turkey to provide better Wi-Fi experience in our customers. So at the beginning of my presentation, I said that Turkcell is a digital operator. So digitalization is a key for us. We have digital services such as instant messaging app BIP and BIP video conference. And Turkcell also tried to engage global partners, not only in-house digital services and applications. The latest example of this partnership with NVIDIA, actually. Turkcell announced GeForce Now in Turkey this year to provide better online gaming experience to Turkish players in their home. Digital business solutions was a huge digitalization step for Turkcell also. With the DBS, Turkcell create extraordinary service portfolio to enterprise domain, largest data centers, SD-WAN services, and healthcare solutions. So, okay, what is the Turkcell fixed broadband strategies? We believe that Turkcell is technology-oriented operator. We always try our best to invest and work new technologies. We create long-term technology roadmap to cover all our service domain, such as home, business, and to cell site. You can clearly see that for home, we are giving XGS-PON on-demand and Wi-Fi 6 services to residential to create a better experience. And we also have very huge ETTX domain in Turkey, not only GPON. So we are trying to modernize that topology with the XGS PON nowadays. For business, right now we can able to give 10 GPON, but the further needs for bandwidth will be covered with the next generation PON technologies. For cell side, we believe that with the 5G era, we have to give much sufficient bandwidth for the cell side routers. To be leading on the home broadband and digital services and the fixed mobile convergence, we should keep up this pace and we should track the technological developments. When we talk about home, we are the only operator that provides 10 Gbps on demand and provide Wi-Fi 6 home gateways in Turkey right now. But does it enough? Yes, for now. But new services like cloud game and VR require higher bandwidth consumption and low latency requirements. To provide solution for such requirement, our strategy is expand FTTH footprint and provide multi-gigabit bandwidth with low latency to end customers. We believe this is a very important step for customer experience. We can do that with 10 GPON investment and Wi-Fi 6 solutions. 10 GPON seems to more than enough for next 5 years for the residential business, we believe. Turkcell invest FTTH network not only for the broadband. We can deliver 10 GPON to our business customers also with our existing FTTH network. This model, actually, we are working like more than 10 years. We give business and the cell sites from the FTTH network, and we will keep doing with the new next generation PON technologies. But increasing demands on the new low latency requirements, much more critical and urgent in the business services. Maybe not for the residential, but business services very critical for that kind of perspective. We can clearly see that usage of video meeting applications, electronic whiteboards, and cloud computers increased dramatically with the COVID-19 pandemic. For that increasing demand, we should provide efficient bandwidth and latency service to our business customers. Turkcell has also has a campus Wi-Fi service that provide a Wi-Fi coverage for university campuses in Turkey. We also upgrade campus Wi-Fi solution to Wi-Fi 6 last year. With the Wi-Fi 6, high bandwidth needed. So near future, multi-10 giga capacity requirement should be realized, and I believe 50 GPON is the best fit for that. When it comes to cell site business, mobile backhaul business, I believe that Turkcell one of the pioneers when it comes to fixed mobile convergence. Almost 10 years ago, when we deployed our first GPON infrastructure in Turkey, we started to provide mobile backhaul service from the GPON to the cell site. I believe that PON technology is the most efficient way to create hybrid and converged network for ISPs and mobile carriers. Because of the fiber is most valuable asset for ISP. For mobile carriers, spectrum is really critical. But without a good fiber connection, I think spectrum itself does not do the job. For LT sites, nowadays, GPON and XGS PON is more than enough. But when it comes to the 5G, capacity per site will be 10 Gbps. And providing bandwidth multiple cell sites from a single fiber core, it will be a challenge. And not only for the mobile backhaul and midhaul, we should provide a solution which covers midhaul and fronthaul solutions. I believe that development of the 50G PON standards will cover all requirements for these applications and in a most efficient way. To summarize my all slides, we can say that Turkcell has a strategy that to reach all country with the fiber in the all domain. This is one of our biggest strategy we have. And while we are doing that, we have to keep up the technology pace. Like for residential, we should deploy 10G PON and Wi-Fi 6, like other operators do nowadays in Europe and China and the United States, maybe, for the residential, because the 4K usage is increasing and cloud gaming is coming, and the other vertical industries is very important. And for the mobile sites with the 5G, we definitely believe that 50G PON will be the best solution to optimize fiber efficiency for the ISPs. And after regulatory approval in Turkey, maybe 2 or 3 years later, we have to definitely start deploying 50G PON when it will be ready. I think most critical requirements for the 50G PON should be, of course, the high bandwidth, but the low latency is very, very important. Because if you want to make any midhaul and fronthaul solution for the mobile cell site, it's really, really critical, getting low latency. And of course, high reliability. And that was my last slide. Thank you for listening.
This presentation from Turkcell, having the feedback from actual operators and feedback directly from the trench is always extremely fruitful. I keep from you what you said about this low latency and high reliability question, which seems to be key when moving to next GPON technology. So thank you again. We receive a lot of questions, but I encourage you to keep posting questions. Either we will come back to you directly via the question box, or we will address your question at the end of this session. Let's move on now to the next speaker. We will pass the floor to another operators, Mr. Lee Junwei from China Mobile, who's a senior research engineer at China Mobile, will now talk about the requirement for 50G PON and the technical solution that China Mobile has put in place for 50G PON. So, Mr. Lee Junwei, the floor is yours.
Okay. Good morning and good afternoon and good evening, everyone. This is Junwei Lee from China Mobile Research Institute. Today, I will share some thoughts and vision on 50G PON. This slide consists of two parts. First part is to discuss the requirement and the analysis of 50G PON. The second part is to discuss technical solutions and the current status of 50G PON. In this page, according to the information from Omdia, annual network traffic growth rate is up to 28.7%, which means traffic increases by 2 times every 3 years. If we analyze the traffic composition further, it could be uncovered that video dominates main traffic. What's more, new radio service experience, such as 4K, 8K, and even VR requires higher bandwidth. Here are some wireline broadband operation and customer data of the CMCC, from which we could see that the number of fixed broadband user scale has reached 215 million by this February, and the individual user access bandwidth is more than 100 megabits. In order to meet the current bandwidth requirement, PON has been upgraded into gigabit system, which means all of the OLTs in the field area could offer 10G PON ports. Meanwhile, relevant research work on next generation PON has started to match new scenario in the future, and the 50G PON field trial is on agenda. From the figure below, this shows the course of PON development in China Mobile. There are some important time point. We choose PON to deploy as FTTX technology from 2009, and after 7 years, we began to deploy XGS PON as the upgrade generation PON after GPON, and we plan to have some plan to discuss the deploy 50G PON will be around after 2022. In this page, we will discuss 50G PON technology requirements. One of 50G PON technical requirements is to support smooth evolution. From our point of view, since adjacent generations of PON need to coexist, it's preferred for us to utilize GPON wavelengths for 50G PON to support coexistence with XGS PON. As an infrastructure of access network, ODN is not easy to deploy, and the cost is high. So reuse of ODN is a key requirement for us to be considered in the evolution of PON. All ODNs on China Mobile's field network are deployed based on C++. So to reuse existing ODNs, power budget meet 32 dBm requirements for 50G PON. In our deployment experience from GPON upgrading to 10G PON, the combo method is relatively convenient method to support ODN reuse based on experience. In this page, we will discuss the 50G PON technical requirements to support a new scenario. In 5G small cell backhaul, 50G PON could be required, and the feature of TDM PON, the topology of point to multi-point, which may reduce the cost, and it might match the requirements of backhaul for 5G small cell well. Thus, the demands for 50G TDM PON probably could be ahead of schedule, and delay and synchronization performance should be further improved. According to 3GPP spec, different services have various demands on delay. For example, URLC service need a 0.5 delay, and EMBB service need a 4 millisecond delay from end to end. Given the demands of backhaul for splitting and the aggregation ratio will be less than fixed broadband, the demanded bandwidth for each OU will range from 1G to 10G. The delay is expected less than 350 microseconds, and the synchronization accuracy is expected less than 50 nanoseconds. So 52 PON is a pretty promising contact to match them. In this page, we will discuss key feature requirements and technology of Hdpa to support the requirement discussed above. So in addition to higher bandwidth, 50G PON should have new ability to support lower delay and higher synchronization accuracy, as well as multi-service integrated access, so that 50G PON can access both traditional fixed broadband service and backhaul traffic from 5G small cell. The following will discuss the corresponding key text to support the key features mentioned above. The first key technology is to meet 32 dBm power budget. The key technologies to realize 32 dB OPL typically include TX and RX technology in optical and electronic components. 50G PON can adopt 25G and 50G EMF transmitters with SOA to obtain high launch power in TX direction. And high sensitivity 25G and 50G HD could be used in RX direction. Additionally, the Dsp tags could mitigate the dispersion penalty after 20 kilometers and eliminate the signal distortion and ISI in system. While high gain FEC could be introduced into 50G PON to further improve the power budget. At the current stage, 25G optics with Dsp is a viable option for 50G solution. Firstly, Dsp is required to compensate optical signal deterioration due to high speed. Secondly, 50G PON based on 25G optics could benefit low cost and reliability at the current stage. And moreover, 50 optoelectronic components with sufficient bandwidth might alleviate the complexity in Dsp. Here's a survey about the current status for 50G PON industry. Continuous mode device and chips are technically ready. The burst mode components are still under development. Besides, mature and commercial 50G optoelectronic components with sufficient bandwidth are moving forward. Another focus on key tags of 50G PON is how to approach to lower latency and higher accuracy synchronization. So the 50G PON performance of latency and synchronization could be improved in several ways by optimizing communication layer implementation. As known to us, periodical opening activation window is a basic procedure for TDM PON to bring UOU up, but it will add additional delay to the traffic from operating ONU. The upper left figure shows one way to alleviate delay. After using a third dedicated wavelength for serial number discovery and ranging, 250 microsecond delay can be reduced. The upper right figure shows another way to do so. Multi-burst in 125 microsecond frame time means 125 micro time slot is divided into several smaller sub time slots, in which ONU bandwidth allocation period can be reduced so that the traffic delay could be lower. Meanwhile, TDM PON is such a system is with natural synchronization speed, so it's hopeful to realize 50 nanometer synchronization accuracy after systematic optimizing. The new experience-oriented architecture that we come up with is a key feature for the next generation PON access network. There are three aspects of key characters for this new systematic architecture, including SDN, slicing, and smart. Of course, there are lots of specific tech to support them. This architecture could support carrying multi-service with differentiated guarantee of the experience and support new function efficiently and flexibility by control panel and user panel decoupled technology. And in this page, we will review the progress of ITU-T high-speed PON standard. ITU-T began to study the high-speed PON beyond the 10G at 2015, and in 2018 February, ITU-T Question 2 group agreed to start higher speed PON standard based on 50G per wavelength line rate with support from major operator and vendors around the world. And the 50G PON standard was originally planned to be released in 2020. And the recent plan is to be done in 2021. And in the end of this presentation, here's some summary. Firstly, based on the experience from research and the deployment of GPON and XGS PON, 50G PON is a preferred candidate technology as next generation after XGS PON. Secondly, call for our whole industry chain to contribute to 50G PON further so that high power budget challenge could be overcome sooner. The third one is deployment requirement of 50G PON in 2C market might be ahead of 2H market. Given the 50G, given that 5G small cell backhaul requirements will be getting energetic from 2021, and the new experience-oriented architecture is a key feature for the next generation PON access network. So that's all. Thank you for listening.
Thank you very much, Mr. Lee Junwei. That was a pretty exhaustive and fascinating presentation, very detailed as well. So many thanks for your input here today. I see that we have a lot of questions in the question box. I would like to emphasize the fact that this webinar is currently recorded and will be available for offline vision from Monday on the EDAT website. So if you wish to review this presentation, or if you want to advise some of your colleagues to follow some of those presentations, they will be available on video. Moving forward, and after having heard the feedback from 3 operators, I would like now propose you to move to some technological question. I mean, obviously, when it comes to new GPON technology, and especially 50G PON technology, we are facing various challenges. We have the pleasure today to be joined by Mr. Robin Kung from Sumitomo. Sumitomo is an expert at optical components and will basically present us the progress that Sumitomo has been doing into optical component when it comes to 50G PON. So Mr. Kung, the floor is yours.
Hello, everyone.
Yes.
Good morning. Yeah, good afternoon and or good evening. Yeah, it's very glad to attend this Adidas invitation, the webinar. This is Robin from Sumitomo Electric. Yeah, our company have been in this market for long terms. We are detecting the 3-5 family-related semiconductor material products, such as laser diode, photodiode, and SOA. Today, my presentation will include 5 topics to cover. The first one is 50G PON specification analysis. The second one is 50G high power EML. The third one is SOA integrated EML. The fourth one is 50G TO package. The fifth is 25G and 50G APD. Firstly, this is the standard for the PON history, include 10G, 25G, and 50G. In last year, IEEE have published the specification for the 25G EPON and 50G EPON. Now, ITOT is discussing about this 50G PON. Now, ITOT is only handling 50G PON, not include of 25G PON. So today we will mainly discuss about this 50G PON. Yeah, this page shows our Sumitomo OSA history for the PON market. So we have been support this market for long terms, include of less 1G, and 10G both are in the history. And now currently, so we are supporting the market mainly with 1577 nanometer EML. And in parallel, we are making the preparation for the next generation PON technology and products, include of 25G and 50G EML-TO and APD-TO. Yeah, this page is a reference diagram of 50G PON. This is from the temporary document from the ITOT. The left side is the OLT side, and the right side is the OU side. Now, ITOT is only discussing about this downstream direction optical spec. So today, we will mainly focus on this OLT transmitter side and OU receiver side. This is a summary about the power leak budget. So each class of the IEEE and ITOT. So you can see for the ITOT, so the A1, class A1 is 29 dB, and N2 is 31 dB power budget, and class C plus is 32 dB. The transmission distance is 20 kilometer. Yeah, this page shows the downstream direction optical spec. This is under discussion. So ITOT have defined the wavelength already. It's 3042 nanometer. And regarding the sensitivity, based on the IEEE 25G sensitivity requirement, minus 24.1 dB, considering the sensitivity penalty about 2 dB from the 25G PON to 50G PON. So we calculate the sensitivity requirement for 50G PON is minus 22.1 dBm. And considering of 2.4 dB tag, so we calculate the requirement, the minimum OMA power requirement from TI side is 9.3 dBm for the A1 and 12.3 dBm for the C+. Yeah, this is okay, just a moment, please. Yeah, from this page, I will explain Sumitomo's activity, how to achieve the OLT side OMA out power to meet the spec, and how to achieve the receiver side the sensitivity to meet the spec. For the receiver side, I mean the sensitivity study, we have finished the simulation for the 3 solutions. This page shows the first solution. We use the 25G APD plus DSP to make the simulation. The DSP setting is FFE is 9 types. The left chart shows the sensitivity result based on the 25 gig back-to-back addition. We got the sensitivity result is 20 26 dBm. And the middle page, we got the 50G back-to-back sensitivity result is 24. Sorry, this is some overlap. Just one please. Yeah, and so we can calculate. So from the 25G to 50G, the penalty is 2 dB, so which is good agreement with ITUT character baseline. And after a 20 kilometer transmission with the RF parameter 0.4, we got the sensitivity result is minus 21 dB. So confirm this optical path penalty is around 2.7 dB. Yeah, this page we showed another two solutions about the 50G APD. Yeah, the 50G APD plus the CDR and the 50G APD plus the Dsp solution. In the table, so the FFE off means CDR solution, FFE on means the Dsp solution. So the same as the 25G, the Dsp setting is FFE is 9 taps. So from the middle chart, so you can see we achieved the under the 50G back-to-back condition, we achieved the CDR solution is minus 24 dBm, and the Dsp solution we also got the 24 dBm sensitivity. And after the 20 kilometer transmission with RF parameter 0.4, we got the sensitivity result with CDR is minus 20 dBm, and with the Dsp solution is minus 21 dBm. So we confirm the OPP with the Dsp is estimated to be 3 dB. Yeah, this page we make the summary about the three solutions with the different alpha parameter. So we will have 3 key comments here. The first one is the alpha parameter is 0.4. It's a reasonable assumption for the EML. And the second one is 25G ROSA plus Dsp meet the proposed spec and seems the best option based on this simulation model. And the third one, all these results are based on the FFE only. The better sensitivity and the lower dispersion penalty can be further derived based on the strong Dsp algorithm as discussed in standard. Example, FFE plus DFE, or FFE plus MLLC. Yeah, by last page, we can see the simulation result about Dsp. From this page, we will discuss how to achieve the output power for the to meet the 50G PON OMA power spec. In the left chart, the gray line shows the PI curve of our current O-band EML chip, 50G EML chip, the output power. Yeah, and we will make the DIP structure optimization, and we will have the blue line PI curve. So you can see under the 100 milliampere current condition, we have achieved the 16 milliwatt output power. And the right chart shows the right chart. So the blue spot shows our current available wavelengths. So some is in mass production, or some is the wafer trail results. Regarding the 3042 wavelengths, so we will make the fine tuning based on carrier O-band. Based on the carrier O-band DFB, and we will achieve the wavelength requirement. This page shows the EML bandwidth and ER trade-off shape. Usually, in order to increase the between ratio for the EML, we will increase the modulator length or width for the for the EA section, but we will increase such a modulator length section. Usually, the parasitic capacities will increase. It will lead the reduce about the bandwidth. So we need to find a good balance for the between ratio and the bandwidth. Yeah, this page shows our measurement result about EA modulator list depicted with the bandwidth and with the exchange ratio. You can see we have found a good modulator list to achieve the bandwidth and exchange ratio spec requirement. Finally, the bandwidth is wider than 37.5 GHz, and the exchange ratio is more than 7 dB. The driving condition is 1.5 APP. Yeah, in order to further increase output power, so we are considering SOA integrated solution. SOA integrated solution is suitable for the 50G PON result. Yeah, our Sumitomo have developed the SOA integrated EML for the C byte and L byte of the TWDM PON application. And we confirmed the SOA gain is about 4.5 dB. Regarding this 3042 nanometer version EML, we will increase the SOA based on the last page, the high power EML. Yeah, and plus this 4.5 dB SOA gain, you can see under the 100 milliampere, and so finally we can achieve around 45 milliwatt output power from the chip. In other words, 16.5 dBm. And the left table will make the power budget calculation, assuming 2.5 dB coupling loss for both manufacturer. So using this SOA integrated EML, we can achieve 12.3 dBm OMA power under the 7 dB ER. So it can meet the C+ requirement. This is our 50G OSA package bandwidth simulation results. We use the standard coaxial type package and achieved more than 40 gig bandwidth. And because there is the SOA section, we need additional 1 pin for the SOA character supplying. Yeah, by last page, we finished the EML introduction. And from this page, we will show some of our actual activity about the APD products. So firstly, so this is our 25G APD, waveguide APD, actual testing results. The left chart shows the two types of APD technology. The blue part is a back illuminated APD, and the red spot is the waveguide APD. You can see, so the waveguide APD, the bandwidth have increased a lot. And the middle chart shows the trade-off reshape between the bandwidth and the M factor. The red chart shows our 25G APD ROSA actual testing results, BR testing results. You can see under the BR is 1E-2 condition, we achieved the -26 dBm sensitivity. And considering this 2 dB penalty from the 25G to 50G, -24 dBm sensitivity is achievable. Yeah, this page shows our 50G APD feasibility study. This product is under developing. The main characteristic is listed on this page. Firstly, edge-illuminated waveguide structure, and we have achieved the wider bandwidth APD. The bandwidth is wider than 37 GHz. And the APD responsivity is bigger than 0.7 ampere per watt, and also integrated the spot size converter. APD analyzation coefficient is about 0.25. So finally, back-to-back sensitivity is -24 dBm under BR condition 1E-2. Yeah, the below chart shows our simulation results about the bandwidth and the M factor. Yeah, by now, business, I finished my main instruction. Let me make the brief summary. Sumitomo can provide EML SOA and APD to achieve 50G PON requirement. EML-schooled bandwidth can make 50G ARZ operation, and SOA gate can obtain high output power. And our APD sensitivity can meet the ITOT requirement. Yeah, that's all my presentation. Thank you.
Thank you. Thank you very much, Robin, for this presentation. Obviously, Sumitomo has made several breakthroughs when it comes to the improvement of the optic component. So many thanks for this presentation. Let's move forward and let's keep talking about the technological aspect. Having talked with Sumitomo, I would propose now to move to Jacob Machen from Semtech. Here, the main point that we will discuss is the development of PON PMD chips. Having talked about the optical component, let's move to the chips issue. So, Jacob, I leave you the floor.
Yes, hello, thank you. And I'd like to say thank you to the previous presenters for such good presentations. So just to introduce Semtech, we are one of the leading suppliers for PMD chips in the PON market, mentioned, and the product definer for our PMD chips for PON. We'll be talking about the market, the PON PMD, where that fits, and then technology in the OLT and the ONU. So I feel previous presentations have given a very good indication as to why we're doing this. Just a quick summary. I mean, we see gigabit services and Wi-Fi 6, very high density fibers, and general global infrastructure investment as well. So Semtech deliver PON PMD chips for both the ONU and the OLT. And that includes continuous mode devices in the downstream and burst mode laser drivers in the upstream, burst mode TIs for the OLT, and burst mode receivers. These devices are already available for 10G PON and are shipping. And there's a proposal on the table now for asymmetric and symmetric 50G PON. And there's several ways you can see us actually implementing this. There's been a lot of talk about DSP. So if we have a look at the Dsp Solutions on the table, in the OLT, you'd have a PON NAC. In the downstream, you'd have a interface, which is either 2x25G NRZ or 50G PAM4 to the DSP. And then DSP would drive the 50G email driver. Just to note, the DSP tech is actually available at the moment, and the 50G email drivers, that's mature technology this year. So that's good. And Sumitomo gave quite a nice presentation about their emails. And then also in downstream in the receiver, you could use a 25G APD, but that's mature technology. We could reuse existing Semtech continuous mode linear TIs from our PAM4 data center market. They would fit quite nicely in this application when driving a DSP. And a DSP in the ONU, that would also be available. In the upstream, so it depends on which way the market goes. See the standard has 3 different data rates defined from 12.5, 25, and 50G. So the DSP would drive a burst mode driver. And for 25G and 12.5G, that technology is available. We would build on existing 25G burst mode drivers and drive a DML. If you want a 50G burst mode upstream, then you have to talk about where is that an email or a DML, and that may need some further study. Also in the upstream in the OLT, you have a 25G APD, and the 2 different TIs here. There's a 25G burst mode TI, which supports 12.5 and 25G. That could drive a DSP. And in the future, you could have a 50G burst mode linear TI also driving the DSP. The DSP would return that data to the PON MAC using whichever interface, the 2x25G NRZ or the 50G PAM4. So yeah, lots of this technology is mature. Some of it needs some development and is coming out soon. Another way you could do this is with analog techniques. So in the OLT, you could have an analog combo chip, which integrates the 50G email driver as a ASP. ASP is analog signal processing, so it uses analog techniques to provide the equalization. And in the ONU, you could also have a combo chip as well, where you have analog signal processing for the 50G receiver, and that would be integrated with a burst mode transmit. It could be available sometime later, maybe in 2022, but we're building on existing technologies. So in the OLT, actually you need a burst mode TI, and there are two things here. There's a 25G burst mode OLT TI, and here's a picture of it. This is one of our 25G burst mode TIs, which is in our lab, and here's a measurement of its burst mode settling time. And this is actually compliant to the timings in ITU. And there's a lot of headroom. You can see when the reset is issued to the TI and the new burst comes along, the TI is actually settled a lot before the reset actually deasserts, and that provides a lot of headroom to the other chips in the OLT. So this multi-rate is for asymmetric 50G PON, which is where the ITU recommendation is going to first. It's very low noise, enabling sensitivity, and optimized for 25G APDs. In the future, we could take this on to a 50G burst with linear TI. That would also be multi-rate, but it would be a slightly different development where it's designed to be linear within the whole burst mode dynamic range, optimized for 25G APDs, and would work in combination with the DSP or the analog solution. Now in the OLT, you also got a combo chip, let's say. We have an asymmetric OLT combo, which would have the integrated 50G email driver. And if we were to choose a PAN4 or 2x25G input, we're very interested to know where the industry might go with that. But if you were to use a PAN4 interface, this is a stress die, which you would have on the input of our chip. And we will convert that into a 50G NRZ optical output. And here's a measure die from one of our existing 50G transmitters. Then in the receiver, you have the output from the 25G burst mode TI, now at a reference bit error rate of 1E-2. The signal to noise ratio is going to be very poor. So in the receiver, we have a burst mode CDR, which locks to the new phase and slight offset frequency very correctly and meets the ITU timings. And then at the end of the transmission line at the MAC input, you'd have a pretty decent I where you still have the bit error rate of 1E-2. It's quite important because the module interfaces have very high insertion loss. So for symmetric OLT combos, we'd like to have the same 50G email driver as the asymmetric one, and we'd have a 50G multi-rate burst mode OLT receiver, a slightly different device where we would have to provide equalization to account for the APT response and dispersion of the fiber. The type of equalizer there really depends also on the ONU transmitter, if that's a EML or a DML transmitter. So in the ONU, I think we'll start with the asymmetric 50G ONU first. So you would have a 25G DML driver. That would be targeting the objective times in ITU for the burst on time. And we're building on our existing knowledge for 25G drivers. And the receiver, that's also very interesting. That could either be done with a DSP or analog solutions. If you look at the eyes here, you've got the fiber input eye that has a lot of high frequency noise on it due to the way these are the DFB and the SOA. And then at the end of the fiber, you've got dispersion and a lot of ISI. But if you look at the impulse response of this system and with various APD-based TI roses, so here's a picture of one of them, and this is an existing Semtech TI. You see a lot of ISI, and that then requires a multi-tap equalizer. So an FFE/DFE receiver could equalize this, and that could be done using either DSP or analog solutions. Then the output of this chip would either be a 2x25G NRZ or PAM4 output to the host ASIC in the ONU. So for symmetric 50G, this is where it becomes very interesting. And what is the 50G transmitter going to be? Is this going to be an email driver or DML driver? I appreciate the ITU recommendations leaving this for further study. I feel both are plausible, both are possible. There are some trade-offs on each. So if you have a burst mode DML driver, you perhaps need a very high voltage swing at 50G on the input of its modulator. You need a burst mode BIOS driver. It may need an SOA, so you may need to burst that on and off as well, and perhaps sequence them. But all that results in perhaps longer burst on times. So you need to take that into consideration for the burst mode overhead for the system. And because that's an email, you perhaps have less dispersion of fiber, so perhaps you need less equalization in the OLT receiver. If you were to use a 50G DML driver, well, that would be a burst mode DFB, so you would have shorter burst on times, which is nice. Perhaps lower solution power. The driver itself, so the modulation driver itself, could be more complicated. It's a bit more difficult to drive DFBs compared to an EML. And because it is a DFB, you may end up with more dispersion in fiber, so you may need more RX equalization in the OLT. All this requires a bit further study. Be very interested to see where the industry goes here. And for both, we'd use the same 50G ONU equalizing receiver as well as a combo chip. So, in summary, from our point of view, the 50G PON PND, yes, it's all achievable. The asymmetric, especially, that uses mature technology that's available and in development. For symmetric 50G OU and OLT, yeah, that also looks achievable as well. That's also in development too. So, thank you very much.
Thank you. Thank you very much, Jacob. Thank you for this very detailed presentation. I guess the words that need to be kept from your presentation is mature and achievable, which is basically the final conclusion of the work that you have been doing at Semtech to circumvent the various technological challenge that you have met. So thank you again for this very nice presentation. Now, going forwards and before moving to the Q&A, we are still more than 200 people online. So I would like also to thank all the participants who have followed these different presentations. So before moving to the Q&A, maybe we could do a little poll exercise again, as we did at the beginning of this session. And let me ask you first a quite daring question. Obviously, we have mainly spoken about 50G PON here. Would you choose 50G PON as the next step beyond 10G PON, following to the various presentations that have been made? We have said during the beginning of this presentation, we've seen from the poll that there was still a lot of information needed when it comes to 50G PON. So basically here, the question would be, do you think it's a credible next step beyond G-point? So I leave you a couple of seconds to answer and basically get back to us. So let's wait for a couple of seconds. It's only a yes or no answer. 3 seconds, 2, 1, and let's see the results. Wow! Oh yeah, very impressive, very impressive. Obviously, all speakers have been extremely convincing. with this massive answers from the participants. I mean, obviously, this is not a scientific exercise, but it's quite interesting to see that at the beginning of this webinar, there were a lot of questions on GPON, and I would take this last answer as a very positive feedback to all our speakers and the richness and the details that have been provided during those presentations. Maybe a last question before moving to the Q&A, which is clearly a feedback for all of us. Was this webinar helpful? And clearly, based on your answer, we would at EDAT think of maybe organizing other webinar touching those technological issues. So I'll leave you another couple of seconds to get back to us. It's basically just a yes or no answer. 3 seconds, 2 seconds, 1 second. Let's see the answer. Up, and we have no answer. Whoa, we don't see the result. Ah, too bad. Bon, too bad, we don't see the result. There must be some technological issue. Let's move forward. Together with my colleague Roland Montagne, we will now move to the Q&A session. I can see that maybe we have the result of the seminar of the up. No. Do we have the results? Oh, yes, we have. And wow, that's the most impressive result. I would say it's nearly a Stalinist result, 100% yes. So thank you very much for all your very good feedback. And on behalf of the speaker, we really thank you for this very positive feedback. Now let's try maybe to move to the Q&A session. There are obviously a lot of questions that have been asked in the chat box. Some of the questions have been already directly addressed by the speaker, I would say offline, by answering to the participants. I mean, when I see the list of questions, I'm pretty sure we won't be able to answer them all. As much as possible for the question that we will not be able to answer, we will push it to the speakers to see if they can get back to the participant who asked the question. So maybe let me pick some of the questions and turn to some of the speakers. There is a first question that I see here on my screen, which is for Mr. Zhang from China Telecom. Mr. Zhang, if you are still with us, there is a question that I'm just reading it out. It says, in addition to bandwidth, what other improvement do 50G PON have in terms of standards? So basically, what are the other improvements that you see from your point of view when it comes to 50G PON? Could you answer that question, Mr. Zhang?
Yes, I can answer it. So you know, for sure, the bandwidth is very important. How to say is very advantageous compared to the previous technologies. But besides the bandwidth, we believe in the 50 gig PON, we will have several other advantages. The first is that we have discussed, addressed by the other speakers, is that latency. You know, actually in the ITOT standard, especially for the HSP, in the requirement document, if you look at it in detail, then you will find that we have very advanced latency requirement defined in the standard. So generally we will have the high-speed PON must accommodate the services with certain latency requirements for the wireless transportation services. Originally, it was addressed in the supplement 666. So the standardized value to be the future study and to be defined, and also the CODB mechanism has been supported. So for the voice, this is very traditional services, and for the internet services, high-speed internet, so it's still to be 1.5 millisecond. This is the requirement. And as for the very new services like the VR or the gaming, so we have very very good, the values for that. So bidirectional latency between the ORT, SNI, and UNI, then would be less than the 2 milliseconds for the interactive those services. So that can guarantee the service experience, I believe. So the latency is the first one. And the second one, we think that, a company with 50 gig PON will also have very advanced SDN technologies in the, the equipment side, which can help the access network to be more intelligent. So, but that was not defined, standardized in the ITOT. Actually, the beta experience achieved by enabled by the beta intelligence of the access network. This topic was started is ongoing. Actually, it was is started in the ETSI 5G the group. So if you have interest, maybe you can look at the work there. So that is my answer. Okay. Hopefully, I can answer the question. Thank you.
Yeah, thank you very much, Mr. Chang. While you are there is another question that I think is directly linked to you. The question is the following: Can 50G PON coexist with other GPON technologies? And what are the considerations to make those technologies coexist?
Actually, I have addressed these questions in my presentation. So, and also I noticed that there is also, audience have some more questions to how to coexist with the 10 gig EPON and GPON. So from the 2020 point of view, as I have introduced the legacy PON technologies, we have the EPON and the GPON, and most likely we will have the 10 gig EPON and XGS PON actually. So when we considering the migration to the future, we don't want to have still the two technologies. So we only have one. That is our target. So that is why the 50 gig PON is selected to be the future. And regarding the coexistence, so certainly we think that we definitely want the two generations coexistence. So, but it doesn't mean that three generations is not interesting. But considering that the service, innovations, you will see that if we look at the services, played by the young peoples, if you look at that, you will see that the bandwidth requirement would be much higher. So the EPON and even the GPON may be not enough now. So you cannot imagine how to use GPON and EPON for the future, 5 years or 10 years. So that is why we think that from the network construction point of view, so two generation PON coexistence may be more realistic and more, service friendly, I believe. Okay, that's my answer. Thank you.
Thank you very much, Mr. Chang. We have another question for Mr. Dogan from Turkcell. If you are still with us, Mr. Dogan, there is the following question. It is said that GPON is being built on a large scale currently, and the 50 GPON standard will be defined quite soon, in some times. So the question to you is: would you consider skipping directly 10 GPON and directly jump to the next technology?
Thank you for the question. I think we have to address high capacity demands before the 50 GPON, because especially with the pandemic, in the business side and the residential side, the capacity demands increasing. So I believe that we have to deploy first XGS PON, 10 GPON in our network to give sufficient bandwidth to our customers. Then with the 50 GPON, we will be ready to step up the capacity in our network. But we definitely have to see the 10 GPON deployment in the field.
Okay, that's very clear. Thank you very much, Mr. Dogan. Another question, which is directly to Mr. Junwei Lei from China Mobile. The question is the following: what are the advantages of 50 GPON technology compared with the current solution in mobile bearer scenarios? You have mentioned that during your presentation. Could you elaborate, please? Mr. Lee Junwei, are you still with us?
Me?
Maybe Mr. Lee
Can you
Junwei.
hear me? Hello? Hello?
Yes, we can hear you. Did you hear the question?
Yeah, I have here the question. Can you hear me?
Yes.
I can answer it. Yeah. Okay. From China Mobile's view, for 5G network, it requires to deploy a large number of small cells in the mature stage to improve coverage and capacity. And the fiber resource are very important for xHaul. And the existing ODN has a obvious advantage in coverage for xHaul, which could be reused by 50G PON. And another advantage is 50G PON can meet bandwidth requirement perfectly. So I think 50G PON will be a competitive tech in mobile scenario. So that's my answer. Thanks.
Okay. Thank you. Thank you very much. Very clear. Very clear. We'll take another question now, and this question is directly to Mr. Robin Kong from Sumitomo. Mr. Kong, if you are still with us, here is the question, reading it out. It's basically saying, it is generally believed that 50G PON can be implemented based on DSP and 25G components. What are the performance improvement points of 50G optical chips? Mr. Kong, did you hear us?
Yeah, I heard your question. Sorry?
Did you hear the question, or do you want me to say it again?
Can you please say again for the question? Sorry.
Yes. So I'm reading out the question. It says, it is generally believed that 50G PON can be implemented based on DSPs and 25G components. What are the performance improvements points of 50G optical chips?
Sorry, so you, how to say, sorry, I didn't get the point of the question. So means the optical power, the chip, so the performance improvement for the 50G PON?
Yes.
This is for the transmitter side or the receiver side, or for both?
It's for both, please.
I think today my presentation have introduced, so our Sumitomo capability to achieve the 50 PON specification requirement include the transmitter side and the receiver side. For both, we should our solution to meet the specific requirement. Yeah.
Okay. Thank you. Thank you very much. Moving to another question, which is mainly for Jacob Machen from Semtech. Jacob, if you are still with us on the line, there is another very pinpoint question here, I think. Once again, I'm stating the question: what are the key technical differences between BM DML DRV and BML EML DRV?
Okay,
Jacob, did you hear the question?
Yeah. So what's the difference between a burst mode EML driver and a burst mode DML driver? I think that was the question.
Yeah.
So the EML driver, you would need to burst the light source on and off. So that's a DFB before the modulator. And EMLs are generally limited in terms of their output power. So it depends on what the standard comes to for the link budget. You may or may not need an SOA. So you need to burst the SOA on and off. So now you talk about two burst mode current drivers, which need to burst on and off. And that impacts T-on time. So you may need to think about the burst mode overhead for the system. And then the modulator, well, that's complicated. The modulator is AC coupled to the driver as well with the EML. The EML modulator is usually negatively biased. So that needs AC coupling. So that needs to be continuously modulating to have any chance of meeting the T-on time. For the DML driver, you'd need a DC coupled modulation driver, and you need to drive large currents at 50G, and that can be challenging. especially since DFBs are not 50 ohms and they're on the end of a transmission line. So you end up with all sorts of reflections back to the driver, and you need to cope with that and still achieve a very good eye diagram for the transmitter, and that can be quite technically challenging. So yeah, there's pros and cons for both approaches.
Okay, that's perfectly clear. Now we still have a couple of questions that are not directly pointed to some of the speakers, so I will basically read the question, and if any of you speakers wants to take over, feel free to raise your hand. There is a question from a European telco that says, would it be possible to go further than 20 kilometers with 5G? Could we reach, for example, 30 kilometers? And if not, for what reasons? Any of the speakers who would like to take up this question? So basically, I'm reading out the question again. Would it be possible to go further than 20 kilometers max with 50G PON?
So maybe I can, how to say, answer these questions a little bit. So can you hear me?
Yes.
Hello?
Yes, please.
Okay.
Yes,
so,
yes, please.
Okay. So you know, originally for the GPON and 10G PON, definitely the standard, we have the 40 kilometers corresponding specifications. For the 50 gig, it just really depends on the optical classes. For the common TC layer, you don't need to worry about it. It can support the 40 kilometers. And for the PMD, it's really depend on the optics components abilities, actually. So if you have the, how to say, powerful transmitter and receiver components, then you can do it.
Okay, that's clear. Thank you very much. And maybe it's going to be our last question for this Q&A session. Again, a question open to all the speakers, so feel free to raise your hand. The question says the following: considering the RF overlay and the 1550 nanometers wavelength, do you have plans for triplexer to ONU sites supporting the 10 XGS PON or 50G PON and the RF overlay 1550 nanometers? Anybody who wants to take up that question? So basically, do you have plans for triplexer on the ONU site? No answer on that one? Okay, maybe on that question we will talk with the speakers and maybe get back to the requester directly. We still have quite a lot of questions, so we'll do our best to get back offline to the various people. I see that we still have something like 60 questions in the inbox, so it's very rich. We'll do our best to get back to you. Once again, we will repost the video of this webinar, so you will have the possibility to read it or hear it again in the coming days. Maybe now it's time to leave the word to my colleague Roland Montagne, who's our FTTX expert, for a couple of words of conclusion to this webinar before the formal closing. Roland?
Yes, do you hear me?
Yes.
Do you hear me? Yeah.
Yes.
So it was really a very interesting webinar across all the performances that will 50G PON allow. I'm completely sharing what has been said. I have the chance to observe FTTH market worldwide, and today we are really at the point of the real convergence of network. Should it be fixed network, and with 5G coming, mobile network? And that's why I see the feature of short latency driven by 50G PON being quite interesting at this moment of convergence of network. we know that since the arrival of GPON and the formidable success of GPON, it was 15 years ago, we have seen several evolution in the network, because there is really a need today of growth, in need of bandwidth, and with a resilient network. We have seen the arrival of 10G PON, of XGS PON, TWM PON also, and today we are really in the period of the new NG PON, with 50G PON being on the map, I would say, and 25G PON also being here. So there will be really a galaxy of solution for the telcos in order to respond to the demand of the market with robust bandwidth, but also to move on the real convergence of architecture between fixed and mobile. So I'm glad to see that the industry today is really in place to see these promises happening.
Thank you, Roland. I think we have collectively met our targets here. I mean, obviously, EDAT targets during this webinar was to discuss the future of GPON technology. We have focused especially on the 50G PON. The key so what's clearly are here that, well, 50G PON seems to go in the right direction, with a lot of effort on the R&D side, and also willingness from operators to deploy this technology. So we can wish to all the members of this ecosystem a bright future for this GPON technology. And we understand as well that 50G PON seems to be quite fit in order to be in line with the 10G PON technology. I would like to thank again all our speakers today for having prepared and presented all those insights. It was a very fruitful webinar. It was very dense as well. I realized that. But I see from the level of the question and the level of engagement from the audience that it was extremely well appreciated from the EDAT community. Thank you again for all of you who have participated today. Once again, the video will be online from next week on EDAT website. There are a lot of questions about the ability for us to share the slides of the speakers. We will check with the speakers if they are willing to share their slides, and what will be agreed to share will be again on EDAT website. Thanks again. Wishing you a very good day, and hope to see you again at the next EDAT webinar. Have a very good day, a good Friday, a good weekend, and see you very soon. Bye-bye.